you see here a string reaching about 15 feet to a lab stool. Okay, you see the string coming up near the camera. I'm going to move it over to the side just a little bit. Now if I reach out along the string, you might be able to see my hand, and I pull the string back and pluck it, you can see a pulse travel down the string. Or if I just flick the string, you can see the pulse travel. Now you can actually see it a little better if I hold the string a little tighter. Now here goes a pluck. I'm just going to pluck it. You can see the pluck go down and back. And you can actually see it go down and back several times. The tighter I pull the string, and you can tell that it's tighter because it's getting more and more horizontal, the faster the pulse travels, and the more quickly it returns. I can time the pulse by synchronizing its returns with the frequency of a pendulum. Okay, here's a simple pendulum. This isn't the pendulum you're going to use. You'll actually use the pendulum on the pendulum stand so that you can accurately measure its length. And you'll know the comparison between the length of a pendulum and the period of its motion, so you'll know how long it takes a pendulum to make a complete circuit. And from that information, once you've synchronized the pendulum by making it longer or shorter, shorter pendulum goes faster, longer pendulum is slower. By synchronizing the motion of the pendulum with the pluck and return of the pulses, and by using the length of the string, which you'll be able to measure with your tape or your meter stick or whatever, you'll be able to determine the velocity of the pulses. Now what we really want to do is determine the velocity of the pulses for different tensions. So here's how we're going to do the tensions. Let me just bring the camera up a little bit. Okay, in order to measure the tension, we're going to use a rubber band. I've got a paper clip. You see the paper clip here, I think. The background isn't the best. Should have worn a darker shirt maybe. But here's a paper clip, here's a rubber band. And of course, as the rubber band stretches, it exerts more and more tension. Now what we're going to do is we're going to use a fixed stretch of a rubber band. We're going to use one, and then one rubber band, then we'll add one and have two rubber bands, and then we'll add one and we'll have a total of three, and then we'll add still another for a total of 4 rubber bands. So we'll have 4 different tensions. And the way we're going to get each tension is this. We're going to take a plastic ruler, clear ruler, solid ruler, doesn't really matter. And we're going to take a rubber band through the paper clip. Now I've got my thumb down on the paper clip. Okay, let's see that. Okay, here's the paper clip. I match the end of the paper clip with the one end of the ruler, and I hold it down firmly. Then I take I take a hook, and I put it through the other end of the paper clip. And then I take my string, and I try to catch that on the hook. Then when I increase the tension on the string, you can see the string here. Okay, as I pull back, you see the rubber band going taut, and then you see the rubber band stretching out so that its end is at the end of the ruler. Then I have a tension in the string, a known tension. If I do this with 2 rubber bands, I'll have twice as much tension. If I have 3 rubber bands, it'll be 3 times as much. 4 rubber bands will be 4 times as much tension. If I let the rubber band go slack, of course the tension goes back to 0 in the string. So that by tensioning the string with 1, 2, and 3 rubber bands, all stretched out to match the length of the ruler, I can get 4 different tensions, all in multiples of the same tension, and I can measure the velocity of a pulse